In this video, we will be talking about nonlinear inequalities. Before we get there, we need to recall a couple of things. The first is basic inequalities. Now, when you had these in years previous, we had something that looks like x is greater than or equal to 4. If we were to graph that, it would look like the following. We'd have a solid dot on 4, and it would go to the right. What this means is that any number we pick must be 4 or more. The next thing to recall are linear inequalities. So in this case, we have y is less than 4x minus 2. What this means is that first, we must graph our line 4x minus 2. So we plot our y-intercept, and then we have a slope of positive 4. The less than sign means that it cannot be on the line, so we're going to have a dotted line. And then we would shade the region below because y has to be less than that line. The next thing to recall is a little bit more recent. It's the intermediate value theorem. And what this entire thing basically says is that a graph will be entirely negative or entirely positive between its zeros. In order to find zeros, we need to be able to factor, we need to be able to use the quadratic formula, and we need to be able to use our calculator in order to find those. To use a calculator, first you must graph the equation, then you hit second trace, go to the 0 option, and then answer the questions that the calculator tells you. In order to solve polynomial inequalities, and any inequality, there are a couple steps we have to follow. The first is to find all real zeros or undefined values of the polynomial and arrange them in increasing order. The second thing we have to do is to determine the test intervals, and then the third is we have to choose a representative value in each test interval and evaluate the polynomial function. So for example, if we have the polynomial inequality x squared minus 2x minus 3 is less than 0, the first thing we have to do is to find the zeros of that equation. In order to do that, we can factor. So this entire thing factors as x minus 3 times x plus 1. If we set that equal to 0, we can set each of these factors equal to 0. When we solve, we get x is equal to 3 and x is equal to negative 1. The next thing we have to do is to determine the test intervals. These two factors split the x-axis into 3 separate sections. One where x is greater than 3, one where x is less than negative 1, and then everywhere in between. So this essentially determines our test intervals for us. It's everything up to x is equal to negative 1, everything between negative 1 and positive 3, and then everything after positive 3. Then we have to choose a representative x value in each test interval and evaluate the polynomial. In order to do this, we have to choose things in these intervals. So let's choose x is equal to negative 2 first. When we do that, we get negative 2 squared minus 2 times negative 2 minus 3, which simplifies to 4 plus 4 minus 3, which is equal to 5. So everything in this interval will be a positive number. Then we have to choose something in this middle interval. So let's choose 0. When we do that, we get 0 squared minus 2 times 0 minus 3, which simplifies to negative 3. That means that everything in this middle interval will always be negative. Then we choose something to the right of 3. So let's choose 4. When we do that, we get 4 squared minus 2 times 4 minus 3, which simplifies to 16 minus 8 minus 3, which again is equal to 5. This value tells us that everything to the right of 3 will always be positive. So our final answer, because we're looking for x squared minus 2x minus 3 is less than 0, is everything in this interval. So our answer will look like -1 to 3. The next example is pretty similar. In this one, we are trying to find when the polynomial x squared minus x minus 6 is less than 0. Again, in order to do that, the first thing we need to do is to find when our polynomial is equal to 0. So we set x squared minus x minus 6 is equal to 0. And I know that I can factor this into x minus 3 times x plus 2. Then we can set each of these factors equal to 0 and solve. Then we need to determine our test intervals. So our test interval is everything to the right of 3, everything to the left of -2, and everything between -2 and +3. Once we do that, we need to choose a representative value in each test interval and then evaluate. So let's start to the left. So let's choose -3. When we plug that in, we get -3 squared minus a -3 minus 6, which is equal to 9 plus 3 minus 6, which is just equal to 6. Because this value is positive, all of the values in this interval will also be positive. Then we need to choose something in the middle interval. So let's choose 0. When we plug that in, we get 0 squared minus 0 minus 6, which is just equal to -6. Because this value is negative, everything in this interval will also be negative. Then we choose something to the right of 3. So let's choose 4. When we do that, we get 4 squared minus 4 minus 6, which is 16 minus 10, which is equal to +6. Because this value is positive, everything in this interval will also be positive. So our answer is when everything is less than 0. And our only interval that does that is this interval right here. So our answer is everything from -2 to +3. Not all polynomials will be of degree 2, however. We can also have higher degree polynomials, but the same steps still occur. So the first thing we need to do is to find all real zeros of this polynomial. But we have to do a little bit of groundwork first. First, we have to add 48 to both sides. In order to make the right-hand side 0. Then we have to find the zeros. So we set this entire thing equal to 0. And you can do this in a lot of ways. You can factor by grouping, or you can use your calculator in order to find the zeros of this function. I know that I can factor by grouping, so we can group the first two things together by factoring out x squared, and 2x minus 3 is left. And we can group the second two things together by factoring out -16, and 2x minus 3 is also left. Then we can factor x squared minus 16 out. To get x squared minus 16 times 2x minus 3 is equal to 0. X squared minus 16 factors into x plus 4 times x minus 4. And now we can set each of these factors equal to 0. When we do that, we get x is equal to -4, x is equal to +4, and x is equal to 3/2. The next thing we need to do is to determine our test intervals. each of these factors splits up our x-axis into different intervals. So we have everything to the left of -4, everything to the right of 4, and then we have 3/2 somewhere in between. So now, instead of 3 intervals, we have 4. We have everything to the left of 4, everything between -4 and 3/2, everything between 3/2 and 4, and then everything to the right of +4. So then we need to test an x value in each of those intervals. So let's start to the left. So let's choose -5. When we plug -5 into our equation, we get -117, which means that everything to the left of -4 will always be negative. Then we have to choose something in the interval of -4 to 1, or to 3/2. When we do that, we get +48, which means that everything in the interval from -4 to 3/2 will always be positive. Then we have to choose something between 3/2 and 4. So let's choose 3. When we plug in 3 into our equation, we get -21, which means that everything between 3/2 and 4 will always be negative. Then we have to choose something to the right of +4. So let's choose 5. When we plug in 5 to our equation, we get +63, which means that everything to the right of 4 will always be positive. So our answer, because we're looking for when this polynomial is greater than 0, we are also looking for the positive intervals, which is this interval and then everything to the right of 4. So our answer will look like everything from -4 to +3/2 and everything from 4 to +infinity. These inequalities also don't have to be polynomials. They can be rational functions. But the same rules still apply. The first step, we find all real zeros or undefined values. Then we determine the test intervals. Then we choose representative x values and evaluate. So for this problem, we're looking for when 2x minus 7 divided by x minus 5 is less than or equal to 3. The first thing we need to do is to move this 3 to the left. Then we can subtract these two things by finding a common denominator. The common denominator for 3 and x minus 5, we'd have to multiply 3 by x minus 5 over x minus 5 to get 3x minus 15 over x minus 5. Then we get 2x minus 7 minus 3x plus 15 in the numerator and x minus 5 in the denominator. When we simplify this, we get negative x plus 8 over x minus 5. Now we can do these steps. So the first thing we have to do is to find our real zeros. So we can set our numerator, x plus 8, equal to 0. So negative x is equal to negative 8. So x is equal to positive 8. This would be our first 0. Then, in order to find the undefined value, we can set our denominator equal to 0. So x minus 5 is equal to 0. So x will equal 5. In the previous lesson with asymptotes, this x equals 5 would be a vertical asymptote. The next thing we need to do is to determine our test intervals, which is everything to the left of 5, everything between 5 and 8, and everything to the right of 8. Then we plug in values in these test intervals and evaluate. So the first thing we need to do is choose something to the left of 5. So let's choose 4. When we plug in 4, we will get 2 times 4 minus 7 over 4 minus 5 minus 3, which simplifies to 1 over negative 1 minus 3, which is equal to negative 4. So everything to the left of 4 will be negative. Then we need to pick something between 5 and 8. So let's choose 6. When we plug 6 into x, we get 2 times 6 minus 7 divided by 6 minus 5 minus 3. When we simplify that, we get 5 over 1 minus 3, which is equal to 2. Because this is positive, everything in this interval will also be positive. Then we choose something to the right of 8. So if we choose 9, we get 2 times 9 minus 7 over 9 minus 5 minus 3, which simplifies to 18 minus 7 over 4 minus 3, which is 11/4 minus 3, which will be negative. Because this value will be negative, everything in this interval will also be negative. So because we're looking for when this function is less than or equal to 0, we're looking for the intervals that are also always going to be negative. So this interval and this interval. So our answer will look like negative infinity all the way to 5, not including 5, and everything from 8 to positive infinity. So why is all this useful? These inequalities can be used to minimize cost and maximize revenue. So for example, a marketing department of a calculator manufacturer determined the demand for a new model of calculator is D is equal to 100 minus 0.00001x. In this case, D is the price per calculator and X is the number of calculators sold. Revenue is equal to X times our demand, which is X times 100 minus 0.00001x. The cost of making calculators is $10 per calculator with a $2.5 million operating cost. So cost is equal to 10x plus 2.5 million. A common question would be, what price should the company charge to obtain a profit of at least $190 million? So from our profit equation, we know that P is equal to revenue minus cost. So if we substitute revenue and cost, we get P is equal to X times 100 minus 0.00001x minus 10x plus 25 million. This simplifies to a quadratic. Then we would substitute our minimum profit value and say that 190 million is less than or equal to this quadratic. Just like any of the problems we just did above, we would first find the zeros of this equation, split the x-axis into different intervals, and then test the intervals. I'm not going to solve this on screen, but what you would get is x is between 3.5 million and 5.5 million. Now, this is just the number of calculators sold. Then we would have to plug this into our demand equation, and we would get P, our price, is less than or equal to $65 and greater than or equal to $45. This means that in order to get a profit of at least $190 million, we would have to charge somewhere between $45 and $65 per calculator sold. So to recap all of this, it really boils down to these steps as shown. For any of these inequalities, the first thing you need to do is to find all real zeros or undefined values of the polynomial and arrange them in increasing order on the x-axis. Then, from those zeros and undefined values, you determine the test intervals. After you do that, you choose a representative x value in each test interval and evaluate the polynomial. The sign of those evaluations will tell us what sign each of those values will have inside those intervals. And that is all there is for polynomial and rational inequalities.